Hi, welcome back. So now, now we will start our sessions for tutorial workshops where you will be allowed to learn how to do programmings for all of the concepts that we have discussed today. So I have provided it in the link on your chat. If you can scroll it, you can see like I provide the link to this website on the chat. The website is site.google.com/view/EICT 2025. So everyone can access to this. And after you access to this website, you would see our web page here. And if you scroll down a little bit, there will be four options for you to use. So we are going to use three notebooks today. Three of them are for three concepts we discussed. First, we discussed about user profiling. Today, you're going to see how the weight terms, how the term-based representation look like, how hierarchy representation look like, what data set can be used in this case, which is very important. And then we are going to practice about how to use LLMs as an agents, which mean like how do we inject the information in, how we create the tools for them, how you do prompting as few short learning, and then chain of thought, which is everything that we have covered today. And finally, you would learn how to create a generative agents for evaluations for your large for your models. So this is the tricky part. I have created the code and it is ready to be run. But for some of you who don't have the API to OpenAI, it might be tricky to run it, right? Because if you don't have access to run it for the notebook 2, you don't need OpenAI because I create two versions for it. For Notebook 3, well, it is like required to use OpenAI as OpenAI and LangChain are interchangeable kind of libraries. So for Notebook 3, at the end, I will try to run them on my machine so you can understand it. And in the future, if you have the API access, you can run it on your own. Right, and then now we will start our tutorials with the quiz. So if you're sitting on your computer right now, I'm not sure how many of you are back, but if you are sitting on your computer right now, I would like you to click on the quiz, right? And you would see like I have created already a Google form for the questions, just to validate your understanding so far throughout the course. You can answer them here and then submit it to me. So type in your email and then like answer it back to me. Okay, so some requests start in next 5 minutes. Okay, so we will wait for another 5 minutes for everyone to be ready. Okay.
Stephen.
Hi. Yes.
So we can, yeah.
Student request to wait for 5 minutes.
Okay. Okay. Sure.
Right. So it has been, yes.
Yes, Stephen, you can start, please.
Okay. So it has been 5 minutes already. I hope everyone is ready. Let me share my screen again. Right. For those who just come back from the break, I would like you to go to this website that I have set it here, or you can look into it in the chat box. So in the website, you would scroll down and you would see the quiz on the right-hand side at the bottom. Be aware that like I also provide solution for each of the notebook. However, like they are not accessed right now because I will open the accession the permissions at the end of the sessions. So may you help me to click on the quiz. And here the quiz, please type in your email. And then like try your best to answer these questions. So remember, like we only use the information that we learned in today's sessions to answer this. Thank you, Suni. Like we don't need to use any something fancy thing. I know you can do some research about other kind of models, but just choose the one we learned today only. uh, right, so I will give you like 8 more minutes to answer these quiz. Thank you. I received 2. Right. It has been 10 minutes. Oh, share the link again. Yes. This is the link to the website. Okay, for those who haven't completed, you guys can do it later after all the coding exercises. Now we talk about our main programmings today. The solutions for the quiz will also be sent to you by the end of these sessions. Okay, so for all of the agents related task, we are going to use LangChain library. So LangChain is a Python library that can build applications for LLMs, and it is very popular to deal with like textualized informations for the large language model and all the NLP's capabilities, because it has been built in with a lot of tools and workflows that can be easily integrated and be rebuilt for your own target. So LangChain is the main thing that we are going to do today. The key feature for LangChain is like it can be combined with different components like change, memories, different kind of vector store, different components for embeddings. And also it is provided with an open API accesses. You can also connect with variety of databases, and you can have more enhanced interactions between models and libraries. Also, you can create different type of prompt engineerings based on library community. They have a lot there, so it will be very easy for you to reuse for some for some research papers. Also, memory management, because it connected with different kind of infrastructure coming out from the API access. Therefore, the memory management is really good, and we can connect and build long-term memory based on LangChain. And it is like one of the pioneer library that support the agentic AI, which means like it enables autonomous agents for the complex task executions. And later on, we would learn how to do that in very simple way. Okay. So why we use LangChain? Because like it's fast, it's really fast. Majority of whatever you read from research papers has been already reproduced in the LangChain. Therefore, it is quite up to date for most of state-of-the-art models. You can reuse them and apply it on your projects easily. Secondly, is like it is very flexible for most of the use cases, flexible for data analysis and documentation summarizations. So on the website that I will show you later, I'll copy this link. I'll copy this link and paste it later. This is like a GitHub contain most of the notebook about agent and large and generative agents at the moment. So you can navigate it and work it out on your own free times. Right. So how to start with LangChain? Starting with LangChain is pretty simple because like everything has been built in with their library. To use like OpenAI and different chain from LLMs, we just have to import it coming out from the library of LangChain. And I like my assumption here is like we have some basic understanding in Python. Therefore, I will just like explain the libraries and some of the new syntax. For some very simple syntax, if you don't understand about it, or you understand about the code, please write down in the chat so we can try to answer it. Right. So for LangChain, first of all, like you always need to define the type of your model in that you use as a backbone for LLMs. In this case, I'm using GPT-4, then I will specify GPT -4 for my model's name in the OpenAI. If you are using GPT 3.5, you have to GPT and then like a -3.5 and then turbo. Right. So to know which kind of model you can have, you need to go to the website of LangChain and navigate different type of models they support. Not all model is there. Like for example, GPT-01 is not there. Yes. And and then we create a simple change. A simple change is just like we are connecting the prompt with your models. And here we call it LLM change. We inject the LLM of GPT-4 that we have specified in the first step, and we're providing our prompts, right? And then we just run it. So so we create a change to get the outside input, like not our prompt, not our like task prompt. It is like outside input, or we call it external documentations. So the change here would like to link from your documents you provided to your current LLMs, because like LLM is a pre-trained model, it's not fine-tuned yet on your task. Therefore, you need to provide an external documentations. And the last step is just very simple. Use the change and run it. So you will have the response as a value, you print it out. Okay, so that is like a very basic one for this. Now we will dive in how to run them in the actual notebook. Before that, I'll just copy this one and I'll put in the chat in case anyone need it. Okay. Right. So still, again, if you don't know where to go, I have provided to you the website link in the chat box. It is site.google view EICT 2025. You scroll down to the bottom, you will see there is 3 notebooks in general. And these 3 notebooks will address 3 of the concepts that we are dividing, that we have been discussing today. First one is user profiling. So I would like you to click on user profile, notebook 1, click on the icon. So in here, please don't run anything yet, otherwise you might disrupt it. The first step you need to do on your own machine is to click on File, and save it to your drive. So next time when you use it on your own, you can find it in your Google Drive. Otherwise, it always stay on cloud as it is mine. So first step, click on File, click on Save a Copy in Drive. Yes. So you see here, like you can change it as you like, your name, your day, yeah, whatever it happens. So next time you can navigate it in your folder. All right. So my assumption here is like we know Python, but some of you might not be familiar with Google Colab or in general with Notebook. So I'll just quickly introduce to it. So Notebook is like a Python power kind of simulations, which mean like you have like two type of components. First is like normal text and then like the code. So to write text like me like this to explain about this information in the notebook, we will use the plus text. To write down any Python code, you will click on plus code here. Right, so that is like two different things. If I use the text and I write a Python code, it would not run anything for me. For example, I write in Hello World and I ship run it, it will not give me anything. And also, if I try to write normal word in the code cell of Python, it might give me an error. It's connecting. Right? So remember, like when you use Python, you have to click on plus code. If you write like anything for your annotation, you will click on the text here. Okay, so next step is to connect to your notebook. So if you click on the drop down button here after you do connections, you will choose connect to host time if you are using CPU. If you want to use GPU for your own computer, we will change the run type and select all kind of GPU and TPU they might have here. Right? It depends on your own use. Okay, so now let's dive into our first notebook, which means like we are trying to understand what does it mean by embedding, like what embedding look like, and how are we going to implement it in Python. All right, so here is a good way for you to visualize it. So in this exercise, you will load a sample dataset that I have already provided. You will learn how to generate an embedding using two ways. First is like the term-based techniques. So in the lectures, I have talked about term-based technique using normalized rating weight. But in your programming, we will try to use TF-IDF, or another term for it, like term frequency, inverse document frequency. And then we will try to generate another embedding that use hierarchy-based technique. And at the end, you will be asked to provide user modeling. So remember, in the traditional way, we have two types: user profiling to get embedding, and to make future predictions, we will use user modeling. And the task will be provided at the end. Okay, so now you have a data set that include three categories. First is like user ID, telling about like the user identity. And second is like the interest of user. Third one is like the categories of user. So this data set is very simple. It's just about the data set of students who are trying to study on a website. So you can see that. So in here, like we have three people. Three people have three different ID. And then we for each people, we have like three different interests. For example, like person one, he like AI, machine learning, and data science. Person two, they don't like it. They actually like cooking, baking, and food. Person three, like a sport person, so he like football, basketball, and sport. So sorry, like this data set is telling about like the activity of the person on a website when they read the news. So the categories that they have been read the news is like they read AI article, they read data articles, and these two in the category of technologies. The second person read the one from cooking, read the one from food, and it's the category of hobbies. The last one read an article about outdoor and team, and it is under the tabs of sport. So now to run a code in Colab, you will use two ways. First, you click on this one is okay. Like you click on the play button here is good. Or the second one is like you shift and then you click on enter. Still run in both way. So after that, we have our data set, and this is how our data set look like. So this is what we call a structured data. So structured data is like when your values can be put in terms of a tabular format, which is like in an Excel row and columns, we call them to be structured. So this is what structured data look like, right? And as we mentioned previously, if it is like structure, we don't need to convert it anymore, right? Because like only when it's unstructured, we will do structured data, and then we will do embedding, and then we will do modeling. But in this case, since it is already structured, so we don't have to do the step of structuralizing anymore. Now we're moving to the next one is to create the embedding. So first step is to create embedding using term-based, or in this case we are using TF-IDF. I believe like when we learn about topic modeling, we learn about TF-IDF is about like the frequencies of each term coming out from each documents. So it can generate the weight of the terms in the documents. So in here, we have a function called term-based embedding, and we throw in a column called interest. So which means like if I throw in the column interest, I would be able to generate an embedding for it. So here we have table of interest. And then here we have like TF, IDF here. Okay. So this is like so I'm just like summarize this because you have run this one before in the topic modeling. So TF-IDF running out the weight here, and it's telling you, so the embedding finally is telling you about like the frequency of the terms from the interest that it happened in the matrix. So this is like how the embedding look like. This is like you can perform some kind of calculations from this already. And remember, this is not a vectors. This is like a matrix or a bunch of vectors. So if you see here, the first two lines represent for user one, the interest of user one. The second two line represent for interest of user two. The third two line represent for the interest of user three. So you see like it looks very lengthy. However, it only represents for three users that we have in the data set. Right. And what we can observe here is like based on my observations, I can feel that like the behavior of user 2 and user 3 are very similar. Like if you can see it in terms of values and in terms of distribution, they are quite similar. Okay, so we have done the first task is to providing term-based embedding. Now we're trying to do the second task, which is like building a hierarchy-based technique. So why we can do hierarchy? Because we see like in this one, we can have like the category. We see the relationship between categories and subcategory. For example, like AI and data, they both belong to technology. So technology is a parent, the children are AI and data. Similar for food and cooking, they are the children of hobbies. And for outdoor and team, they are children of sport. So we can see those kind of behaviors, and we can try to build a hierarchy models on it. So to do that, if you remember in my slide, every time that we are trying to embed something, we will create like a Boolean embedding first. So remember when we do the exercise 2, we do the prediction of movie 5, I always create like different Boolean for each category genre. That's the same thing we are going to do here. So first, like we create like a Boolean for, I did not get number of columns. What do you mean by number of columns? What happened to number of columns? you don't have number of columns in TF-IDF. You like, does it look like this one? Yes, then it should be correct. Then it should be correct, right? I'm not sure what you mean by columns, but like if you got something like this, it is correct. It is called an embedding already. So when it is number in terms of arrays or matrix, it is ready for computation. So it is an embedding already. So it is not a vector like this. This is like three vectors. This is a group of vectors. One vectors, two vectors, three vectors. So you see like every square bracket represent for one vectors. Okay, now we are doing the hierarchy. Now we are doing a hierarchy. You mean this one? Right, so like you have this code, right? You do have this code? Yes. Okay, so what we are doing right now is like so I divide them by Boolean. If something happened, I will put them in Boolean like this. And after that, I will try to use the script to represent for each user. If they have both of these, it'll be 1 1. If they have like these two, it will be like 0 1 1 0. If they have like these two, then they will be like 0 0 1 1. That's the idea, just like what we did with pen and paper in the previous exercises. And we have this kind of code here to look in all these category and put them in the right format with the split by the comma 1. And after I run them, I will use the categories to run it. And now I will have the hierarchy-based embedding. So what you can see here is like, it is kind of different from the TF-IDF embedding. First of all, it looks easy, a little bit more simple, right? Because like it's just telling about like the Boolean, if they are watching AI and data or not. If they are AI and data, if you can see it, we just like plus these two together. User A, right? So you see user A, he has like both technology, AI, and technology and data. What he did was like we just plus into two arrays together. So we have something called 1 1 0 0. Very simple, right? We do the same thing for all the others. And this is the final embedding we have. So row-wise, each of these row represent for each of the user preferences. If it is 1 1 1, it means like he has been watching all of the contents, or like there is sport, outdoor, sport, and team, right? And now when we compare, we will see like, oh, okay, okay, they are much different. And the number from hierarchy-based embedding seems to be easier for computations. But that is my observations, right? I'm not sure. The only way to ensure that like which embedding is better for this task is to run a model and compare them together. So remember, in user profiling, there will be 5 steps. First, we start with unstructured data. Second, we will convert unstructured to structure. Third, we will do embedding, which is we are in third phase right now. The next phase is like we apply a machine learning model in order to predict a rating. And finally, we will evaluate it by RMSE or precision recall, right? Depends on the task, classification regressions. So now I would like you to do an exercise for me in 5 minutes? Yes, I think 5 minutes enough. So in this exercise, I would like you to do linear regressions for a target called DF rating. So help me to do rating for this to see like on which embedding is better. The goal here is to evaluate which embedding hierarchy is better or the term base is better. So we will create this one first. And you will see your DF again. Number of columns. You mean like what does it mean by number of columns? Do you mean like why in TF IDF it has 8 And in hierarchy, that's only 4. Is that the questions? Because I did not get the questions. Right. So in here, in the website that have been provided, if you scroll down, you will see like I provide solution also. Right. If you click on it, after like 5 minutes, I will just provide the solutions. Yep, 5 minutes. Or I can just put the solution here so you can try to type in. Yep. Hmm? Okay. Oh, here. I did not run this. Okay. That's fine. Hmm. Here. Okay. Sorry. Fix it again. Okay, you can see the code that I have provided here, so you can try to type it. Right, I'll just quickly explain it. First of all, we will have to define, because the task here is like we're trying to base on 3 users, and make our models to fit with their ratings. So how the DF look like after we put in DF ratings, the DF will look like this. Our data frame will look like this. So now you see I have put a rating columns. Now my data frames on my Excel file has been added one more columns called ratings. And if you know in supervised learning, we will use them as labels. So which means like we are trying to learn our models to work this and try to find the loss functions coming up to these labels. To learn, we're gonna use the loss functions from the linear regressions. And these linear regressions coming out from the sklearn linear models. So you can just type in the code here. And the metric we are going to use for evaluation is just like RMSE and mean square error, MSE, very simple one. So the goal here is like whatever embeddings that is going to be lower in terms of MSE, then that embedding is better for this task, right? So now I define my labels, which is y is label as the column of ratings. Then I will use chain, train, test, and split in order to split the data set in terms of 70% and 30%. 17% for the training phase and 30% for the testing phase. And we use random state of 42, which is not that important. Any numbers is fine here. Right? And then we will try to build a linear regressions. So the first one, we call it model TF-IDF, which means like this model of linear regression is fit on the embedding of the term-based representations. So we will predict it on the term-based representations right here. Right? And second one is we going to predict it on the representation of hierarchy. So we will predict on the X-test hierarchy here. Okay, for should I copy and paste the code in the chat so you guys can try to reuse it? Yes, exactly. Oh, you can run my code. Okay, I'll just copy and paste the code here just in case anyone need to run it on your computer. Oh, it's right. Now I just make it available to everyone. Oh, okay. Okay, so if you have my code, you run it, you would see there will be like result like this. So this is the result after I run on two representations. If you run it on MSE, your result would be, if you want to run it on TF-IDF embedding, your MSE will be 0.25. If you run it on the embedding of hierarchy base, your result will be 0.08. And the goal of comparison is to find the lower MSE. So in this case, mean square error for the hierarchy base is much lower. Hence, we can slightly confirm that like, oh, okay, for the embeddings, we will use hierarchy base for this case. Does that make sense? So hierarchy-based embedding is better than the term-based embedding here. And the reason for it here is like because hierarchy base is always have more meaningful semantic relationships between categories and between items. Hence, it can explore the informations better than the normal term-based frequency. Term-based frequency only based on the frequency of the items that happen in your in the input. It ignore about all the relationships, therefore it might not be meaningful. However, there's no attribute in different. What do you mean by the number of attribute? So you mean like 4 and 8, right? This one have 8 and this one have 4, right? Okay, yes, because like this one here has been so what the TF-IDF do is like for one column here. Okay, for one column here, it will divide it into two columns. Yes or no? Yes or no, right? So like if you have all these three interests and then the other column is like you don't have all these three interests. So every column has been duplicated as 2, right? So and then you calculate them based on the weight of the terms that has been frequently based in the text. So another word for it is like this one has been one hot encoded. Yeah, it has been one hot encoded, so that's why I have more labels than the others, more columns than the other. It has been one hot encoded. Okay, so the first task here is pretty simple. I'll just give like 1 or 2 minutes for everyone to just catch up, and then we move on to the next notebook. So you can see that like to get a good embedding. So embedding means like we tell about information of a person, user 1, 2, and 3 here. And to understand about those people, we have to go through a lot of steps, which is like quite annoying and take a lot of times and complexity. So from the next one, we would see like how easy it is to inject the informations and reuse them for your own good. For evaluations. Right. So you in notebook you have provided. Yes. So what happened to the notebook? I'll just close this. Last line give error. Okay, I'll just do this one again. Maybe some errors when I export it. So I'll just replace it again. I think like if you reload now, you will see it. If you reload now, you will see the changes. Reload my solution, you will see the changes. You mean like the copy one that I put in the chat? Because like there's limitation of the text. So I would like you to find my solutions on the website that I have provided. So on the website, I have solution notebook right here. You can just click on it. Yes. Click on the solution and scroll down to the bottom to get the code. Okay, now we're moving on to something that is more useful. We call them to be large language model as an agents. Yes, we click on it. And the first step to any notebook that you get from online, you don't run them yet, right? We have to we have to save them to our drive. Okay. So you see like the end goal of user profiling, either using LLMs or either using machine learning, is to get these kind of numbers in terms of arrays, vectors, matrices. So it is very important to know how to do the embeddings. All right, so now we are in our second notebook here, which is like using LLMs as an evaluator agents. So in this notebook, you will dive into two types of promptings that is very popular right now in the world of AI. We call them chain of thought or COT and the few shot in context learning. And you will understand how it works and how to run them. Okay, so first of all, we need to generate our data first. So before that, we have to run in the LangChain community as a library. Now, I would like you to go to ChatGPT to try out to run any content. Ask ChatGPT to write you some of the news, any news, right? And after you ask them to run some of the news, you will replace them here from me. Here I make like very simple one, which is not really good. This is just like placeholder. What I want you to do right now is like go to ChatGPT. Just write down here. We go to ChatGPT website, ask it to write 3 news for you. And then paste each of them here in the quotations. So I'll give you like 4 minutes for this. So for example, I just copy anything that I have on my slide. I'll paste it here. This one. Why can I not paste it? Okay, choose okay, so I'll just copy my slide and paste it here. One more minute. Click on run, right? Shift enter or click on run. And now you have created a data set. Now we check the data set. And in this data set, very simple. There's only two columns, which is like content IDs and then the name of the IDs, right? So in general, from the overview, this is structured data. However, the content is full of text. So if I want to quantify the content's values, for example, I want to know how good the content is, or what is like the semantic between the text in the contents, then it is unstructured. However, in LLMs, it doesn't matter. Whatever it is, the large language model still be able to perform it. But when you use like the previous notebook from the user profiling, you have to use a lot of TF-IDF. You have to use a lot of like pre-processing text in order to get the final embedding. But the good thing in LLMs, like you cut off all those things. Everything is cutting off, and you just fit them into the models. So how to fit them into a model in large language models? So I have created two versions for you in here. The first version is like we are using GPT-2, which is like a model, the free large language model. You can just get it easily from the Hugging Face. So you have to import it and using the text generations here, right? So this means like it has been downloaded, everything is done, completed, and we test it like, okay, what is lang change? This is just like a way to test it, and it gives out the result here. So this is what happened to me. Instead of finding audited base CSV a lot of time, you see that like for a very simple questions, GPT-2 failed to answer it correctly, which means like the ability of comprehension from GPT-2 is pretty low, right? But we are doing this for a demo. That is why like we don't really care much about the accuracy that much. Next one is like we recreate it here. So now I'm trying to change it into my customization. So by default, the temperatures is always 0.8. So like what is temperature? Temperature is like the parameters telling about the creativity and how strict that ChatGPT should be. Yes. So if you put our temperature to be higher, the higher it is going to be like the better in terms of accuracy, but it is less creative. So if you put like high temperature for your large language models, when you want to get the facts, when you want to check facts something, when you want to provide facts of something, but you would like to put out very low temperatures for your large language models of GPT-2 if you want to do like content writing or creative writing. It will give like the more freedoms to of the probabilistic tokens. So like the contents coming out of it to be like more diverse and more interesting. However, most of them is less true, like the facts coming out from lower temperatures. Right, so lang change, yes. So some of you might, so you see like we will have like different results from different computers. That's how random it is. Okay, here we just set 0.7. It's pretty standard. And then like for the response, we will strip them. Okay, so we just run this code from transformer. All of them take from the Hugging Face. So you only use GPT-2 if you don't have the OpenAI access. But I would prefer you to use OpenAI access if you want to implement something accurate and useful. This is just for a demo. Okay, that's good. Right, so now I just run it again to make sure it works. So now it works, right? After I set my temperatures to be about 0.7, which means like provide me more facts, higher facts, then it give me something that is make more sense compared to the first one. Right, so like now my model has been initialized and ready to be used as an agent of AI. Okay, just keep running. I I thought I clean it, but yeah, it's okay. Same thing. Yeah, same thing. Not so like the code here and the code above, they are actually the same, right? I was just like I thought I delete one of them. Okay, so if you see here, you do not run this one. Please do not run the OpenAI. Do not input anything here, right? You can run the cell, but do not put anything here. So for those of you who might have the chance to use ChatGPT in the future, using the OpenAI, you can fit your secret key here. Once you fit your secret key here, you would be able to run your OpenAI models coming out from here. I already create the functions for you. Right, so this is like OpenAI's from GPT-2 from ChatGPT, and it will use the model called DaVinci 0.03. So in the future, if you want to use OpenAI API, you can use it. All right, now go to the interesting part. We have learned that like there is two popular way of prompting for your large language model. The first one is chain of thought. The second one is few shot prompting. So again, change of thought is about step-by-step explanations, which mean like you define different stages of the jobs or of a task, and then ask ChatGPT or the large language model to follow them by sequence. Okay, so you like make very direct and clear comments. What is the first step? What is second step? Give me the answer for that. And here are an example of the prompts, right? So first of all, you are telling them about like what they need to do, or we call it task instructions. And you put in the content here. Content is like the three articles that you have just created, right? And now you are going to ask them about these questions. Okay, ask ChatGPT to do these questions. So why it is important? Because like if you don't ask them about the main idea of the contents, and you are using like very low version of GPT, they might not be able to comprehend the contents, right? So it is important for you to ask them to explain the content. So when you read the results, you will make sure, oh, okay, my GPT is understanding it. So therefore the results is reliable for me to use it. Okay, so the first one is important. If you're using like GPT-4, and this one is you can delete it in GPT-4, but we are using GPT-2, so you must have it. All right. And then we ask them, so here we just ask them very simple questions like, how are the idea is expressed? Give me the rating from 1 to 5. How well is the grammar was written? Give yes or no. Provide me from 1 to 10 over the clarity, accuracy, and relevance. Right. So that is the task that I am going to see from them. And these are the final values that I need to have from it. Right. And in few short learning, it is different. So you see, in chain of thought, we give them a step-by-step things after we tell them what to do. But in here, what we need to do is like give them some example, give them how we rate it. Like, okay, this is a content. I read it 8.10 because like I think it is useful, clear, and something. All right, and then like I give them a second example. So few short here mean like example. Few short learning mean like give them a few examples. So the large language model will understand what to do, and they will follow your patterns to analyze and follow your guidance in the futures. So now you give them two example, like you give 1918, and you ask them to do the next content here. Okay, so that is the difference between the two prompting. And what we just do is just run it. Okay, so we just like loop into the contents row. We throw one in the chain of thought. We throw one into a few shot, and then we utilize large language model, the LM local, to run it to get the results. And finally, we will append these rows into different columns: content ID, COT result, and few shot result. And we print it out. We save it into a CSV file so we can use it later. Okay, now we click on run. Hey, what happened? Oh, okay. Do anyone have the same errors like I did? Oh, I think I put the content is too long. So if you have it, you can either change the max length here to be 1000 or something, or you can, okay, which is my problems. Okay, I put the content is too long here. So I'll just reduce it. Okay. Yep, it'd be fine. Yep, it's done. Mine is done. Right, it has been run here. So we ignore all of these warning, which mean like we have not specified our models clear enough. However, it would not impact too much on our output, so we can ignore it. And when it says evaluations complete, we save them into a CSV file. So if you know how to use Notebook, you would see there's something called folder in here, like files. You can navigate to the folder icons, and you would see, oh, the CSV file you just created has been saved. Okay. So now you would like to see the results. Results underscore df, enter. And you would see this is the result. So this is a result for COT, this is a result for few shot. So you have to understand it by specify them. So I would choose the COT. If I want to know like what is the output coming out from this, I will select this one, right? So you can use log or ilog, but I will just use simple one called index. So I use index 0. Okay. So in here, you can see that like it provide me an answer for the COT result of the first article. It's showing like what is the main idea. It explained a bit, and here is, yep. So like there's some results to be done here. Okay. Right. So what I want you to do is like try to evaluate the results from promptings. Try to evaluate it. Which like I want to see like which prompting is better. Let me print this one out. Because the problem when we use like the free versions of GPT is that like sometimes it's not working. So so like the task here is like I would like you to help me to get out the information from the result and evaluate which prompting is better. So like we'll explore the patterns from the prompting. That makes sense? And I have provided solutions in here. You can have a look into it. Yes, I have it here. You can try to use my solution and improve from that is fine. In the meantime, Oh, I did not give access, sorry. So before you can use this, you actually need to need to do some pre-processing tasks. And I believe like we had that in our previous tutorials on the pre-processing one. Okay. Right. Because like I create the evaluations for the GPT one, so it is might not be able for you to run it. So what I'm going to do right now here is like so the solution is here. Okay. Okay, so what I'm going to do right now is like telling you what's supposed to be done and how should we evaluate it in Agent AI. Okay, so in here I have already provided you the code for it. And what we do here is like, first of all, for all the text that we have run, so all the text that we have run in, sorry, where's my, here, for all of the results that we have run from it, we will explore them and get the rating coming out from this text, because like this is unstructured data. Text values is unstructured. And our goal is to get the scalar or the numeric values coming out from this unstructured data. And in order to do so, I have already written the code that can extract the values coming out from it. So this one is extract the score. It will browse into all of the text and try to find out the score that match it with with the ratings and put them into a columns. Why can you not run it? Like even I cannot run it at the moment because like the GPT-2 is very inconsistent. So if you see here and if you read the results, right? Uh, they explain, they do have some explanation, but they don't give me a clear value. They don't give me any like 1 to 5, 5 to 10. Like sometimes you run, it will give you values. Sometimes you run, it will not give you values. And now I'm unlucky because like now I run it and it doesn't give me any values because it is inconsistent from the free versions, right? So that is something yeah, that is something unlucky. But if you use like GPT 3.5 and GPT 4, I guarantee this will not happen because we are using the free versions. So that's why it was not following what I expected. Right? So after we extract the score coming out from the text, we will just like plot them out, and the goal here is to see like the score rating coming out from them. So I just want to see like if the score from the few shot learning is better, or the score from COT is better for the three articles that we have created, and then we will compare them using a bar chart. Yeah, so if some students can have results, and it would be nice because like mine, I cannot have it right now. Oh, really? You can have it? Yes. Oh, that's amazing. Okay, so yeah, chain of thought score is 1, which is amazing. Oh, okay, so I'm unlucky one then. Right, I'll just give you like 5 minutes break before we moving on to the next one. So I need to check the next one if there's any problems yet. Okay, so I'll stop my screen for 5 minutes. Okay, let's move on to the main one today, which is like using generative agents. Right, so I'm sharing my screen now. Okay, so in the generative agents, you would see that like there's a collab file here. You can click on it. Okay, I'll just check it. Okay, right. Now in this notebook, you will learn how to build a profile for yourself. Like you can whatever your personality is, what job is, what your daily life look like. I would like you to input it in my generative agents under my instructions. Okay, first step first, do not type anything on my notebook, otherwise everyone will be messy. So click on File and save it to your copy drive. All right, I'll just wait for everyone to get in this one first. Okay, I'll give like 2 minutes so you can log in this notebook, the third one. All right, you guys got it? Now I'll try to go to the notebook. All right, pretty simple. First, I would like you to log in your drive. This one. So I will log in my drive. Click on connect to your Google Drive. Click on your email. Continue. Okay. For those of you who are new with Google Colab, there'll be an option called Gemini, which will allow you to help coding. However, like we should not rely on it because most of the time the result would not be correct. ASCII bookmarks token, I got mean 50.5. Yes. So does that mean like few short learning and chain of thought give out the same results? That's interesting. Well, like, yes, like the understanding of GPT-2 is quite limited. So if you can read, like, so like, remember in our prompting, right? We asked them like, what is the main idea of the passage? If your ChatGPT can answer that questions, then these answer might be reliable. Okay, so run to the next one and run the installations on your own computer. In here, we are using all LangChain libraries. So first one here's LangChain community, where like users from around the world try to contribute their code to improve the LangChain library. This is like LangChain library collaborated with OpenAI. This is like the innovative methods that LangChain experiment with. And then this is like FAISS. It is a vector store library. So whatever comes out from your embedding or from your memory will be stored on this one. And Pydantic is like a libraries that will help you to customize existing code or existing object oriented. Okay, so in here we will start importing everything. I also create some local LLMs that for student to use it on your own, but again, it might not be accurate. So I just put it here so you can use them for your own fun or like understand how generative agents work in the futures. But for the accuracy, right now we are still going to use GPT 3.5. Giving error for open or API key. Just wait me a second before I go to that one. Okay, so first of all, we need dead time, we need list, we need open AI, and then like there's a lot of time with retriever, and we have vector store is the FAISS. It is very important to get this vector store. Vector store would optimize the retrieval informations from the RAG models, so it's going to be faster and more accurate. And then we have some embeddings, and it can only be done with the embedding from the open AIs for the chat AI. And then we're having like two of our main libraries, which is like generative agents and generative memories. So generative agent is where we create agents that have your personalities and your traits, and generative agent memory is where you store with the FAISS embedding. Okay, so now we just run it. Sunita, I will go to that part after this. Yeah, can you check, like, do you have the same thing like mine? Like this one, SK Pro or something? Like, do you have like your open API key look like this? All right. So now we are trying to initialize our ChatGPT model called GPT 3.5 Turbo, okay, with temperature of 0. So like I mentioned before, temperature is the most important parameters in large language models. If you put it more than 0.7, it will give you something more factual, but less creative. If you put it less than 0.5, it will be very creative. So here I want, because like it is a human, right? It is human, so I want my human to be very creative. So that's why I set my temperature to be 0. And then like I have the API here. If you click on the notebook here, you would have like the API key. So I think it should be fine. Yes, it should be fine. There's no errors. Can you check, Sunita, if you still have errors? If you still have error, maybe like you need to click on and open it again. Oh, but if you use like new key, I don't think your model will work because like you did not subscribe to OpenAI. So I provided the key here so you can use it on this demo only. So if you can click on my notebook and you will use my key. Yes. Yes, like click on my notebook again. I think like you click it in the beginning of the class, which did not have it. So now I just add the key again. So you can click on the key here. You click on notebook 3 here, and you would have the key like mine. Right. Maybe I'll just wait like 3 minutes so she can catch up. Two more minutes. Don't run all the cell yet, right? Just like follow my sequence. Otherwise, like if you got bugs or any problems, it is hard for me to know ways to fix for you. All right, I think we got it. So now we create two new functions called Revlin score that will base on the similarity score of the text, right? So what we did here is like we throw in some score and then we will compare how relevant they are. This is going to be useful later, not now. And we have another functions called create new memory retriever, because like in our long-term memory from generative agents memory, it have a lot of like indexes that might not be able to retrieve efficiency. So we will use fast like FAISS in order to embed all of those memories in a more dynamic and a more efficient. So later on, when we use like time with vector store retrieval, it will be done. It will be done easier. So like the retrieval will be better. The goal of our embedding here is the fast. So you should be able to run it. All right. So here we have like the avatars. So first of all, like we create an avatar, which means that we create a person here. Okay, we create a person here. We now starting create a person named Tommy. So let's run this one first because I want to have some icon. So I use Pydantic here. What it do is like we customize the original generative agents to add in a new field called an icon, so you can see different people there. Right, so I have here, and then I have an icon of a person. Now let's start building the real generative agents. All those things, they're just like the background installations. Now we are doing the real task. So now we are building our real humans. First of all, we need to create the memories, and which means like just like a human, we create our brain first to store all of our daily informations, right? Here is Tommy memories. We create them using generative agent memories. All of the information here, always keep it like this. We don't change anything. Now we start creating the real Tommy guy. So first of all, I create his face to be a guy with a head icons. I call him as Tommy. So now he is always Tommy in here. I set his age. I set his personality as an anxious. He loves designing. He is talkative. And right now he looking for a movie to watch, and he's free at home in sunny morning of the weekend of the United States. So like that is a status. So what I want you to do right now, just to make it slightly different from mine, you can either change his personality, right, to be something else, like he is humorous. You can type anything you want. He's humorous. He is innocent. Right? He's quirky, something like that. Anything. Status means like what's the end goal that you want him to do? What's the end goal of the day that you want him to do? Right? So here I want him to rate out movies for me, then I would just set it like this. And I click on run. So my agent has been created. Done. That's the first person called Tommy. To check if Tommy is a real man, I click on Tommy's status and I see, okay, his status is there, which means it has been saved in the memories. And now I will click on get summary. So you see, after I do some summary, the ChatGPT 3.5, based on his personality, actually give me a biography of this guy. So it's say like, okay, he was born humorous, innocent, and quirky. So I think he is a hardworking person, dedicated individual who passionate about blah 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 blah. Yep, like that's the thing inferred by ChatGPT, which is good, which means like our model is running. It be able to understand all of these traits and generate something that is not coming up. The API key, really? Does anyone have problem with the API key here? like, does your API key look like this? Okay, some people still fall behind at that. So I'll just check my notebook again. Oh, I think yeah, it's the API key is here already. Okay, so some students still be able to run it. So Sunita, like it's like, do you have the same thing look like this? Okay, I'll place it. Okay, I'll just continue. Like if you still have problem, I'll stay at the back of the class to discuss about it. Okay, anyway, we're moving on. So now we create a summary, and then we have something called observations, which mean like I need to tell what Tommy do a day, right? Observation mean like daily routines that Tommy do. You can be like your own routine you can fit in here, or your friend's routine. For example, like Tommy went to work at 8 a.m. Tommy bought a cup of coffee near his company. Like the more detail of the context, the better that the GPT will be able to understand it. Tommy, I don't know, like bought a bagel or something, a bagels, along with his coffee. Yeah, something like that. And then like Tommy had a meeting with his boss at 9 a.m., which he has prepared the slides previously. Okay, so there's like two activities that Tommy has done so far until 9 a.m. of today. And we will run it to see like how ChatGPT going to observe and understand these behaviors. So you see, like Tommy went to work, he smiled and think to himself, oh, today I hope I have a good day. Because he's like humorous person that I mentioned above, and he's quirky too, right? So that's why and he innocent too. So this kind of reactions can reflect to his personality. He bought a coffee near his car, and he said, "Oh, I hope Tommy enjoyed the coffee." He bought a bagel, and then like a bagel sound delicious. So you see like all of the text coming out from here is very positive, right? Because I create Tommy to be a very positive person. Now let's create a new guy. We call them to be let's create uh another person. We call them to be, I don't know, whatever you want. I will call them to be Alex. Okay, and I call Alex in the year of 20. And let's try to create a person who very not happy with his life. So he's unhappy person. He's selfish. He lazy. He I don't know. Yeah, that's the only thing I can think in my mind. All right. So his status is like he is the boss of the company, and he needs to make the decisions for the next company campaign. For example, like that. So what I'm trying to do is like I'm trying to put Alex as a boss of Tommy. And I'm going to see how these two people going to talk to each other later. That's the goal of generative AI, generative agents, which mean like I want to inspect the social interactions without having it really happen. So we can experiment them in terms of the coding like this, right? And I would say like daily summary is like Alex always scream at people as he is stressful. We just try to create a very like two contrasted people. Stressful. Okay. Because he's lazy, so he's stressful. So we can run it. Right. So if it is like green tick here means like your agents, your avatar has been created. Now we create another person, right? Just for nothing. Just try to see the diversity here, right? We have another person named Bob. Bob is old person. He's like at the age of 35. He's a philosophy who love debating, and he think a lot about different problems. So he's like totally irrelevant to Alex and Tommy. And let's see how they do conversations. All right. So now what we want to do is like we create observations for Alex, just like what we did for Tommy. So I would say like Alex went to buy coffee at 8:30 a.m. Right. And then like Alex meets Alex met Tommy. Alex met his co-worker to discuss new marketing plan. Alex forgot his lunch, for example. Okay. Alex wife is calling him on the phone and complain about their financial issues, something like that. All right, so we try to create like very set life for Alex, and let's see how it works. So we save it in terms of memories here, and we do observations. We also want to see like observations of Alex. You don't have to run it like me. I'll just run it for you so you can see like their different behaviors. So now I change this into Alex. Alex. Okay, let's see how, sorry, I cancel this. It's Alex. Okay, let's see how Alex react to these things. So Alex went to buy coffee at 8:30, just like Tommy, right? And Alex should acknowledge that it make more mental note and punctual in the futures. Okay. Alex met his co-worker and discussed about new plan in marketing. He should take notes during the meetings and actively participate in discussions so he can make more informations in the next day. So you see like all the output for Alex here, all the observation for Alex here is very different coming out from Tommy. Tommy is like the first perspective of kind of views where he's very happy and very pessimistic about his life. But for Alec, he was pretty sad and seems to be very serious about all his problems. So you can see like for different personality, you have like different reactions of the agents, and then they have different opinions. Okay, so now we will run this code where we can talk, like you can be able to talk to them. And so the first function is like you will be able to ask them any questions you want about their daily life. The second question is like where you tell them to have conversation to each other. Does that make sense? So run conversation is like where we ask the agents to talk to each other. The interview agent is like where we actually be able to do it our own. Okay, so for example, I'm asking Alex. Alex is RS, right? And I'll just ask Alex like maybe like what do you think about your wife, for example? And I did not run the experiment before, but based on my understanding is like he might give out some bad comments because like he was built with like terrible traits, so he might give out very bad comments. And let's see how he say. Oh, All right. So it seems to me that like Alex don't understand my questions. Well, maybe we need to ask him again. So you see here's like the answer here is irrelevant to my questions. And it happens quite a lot, right? It happens quite a lot. Why this one is happen? Because like based on my experiment, the reason is that like the even GPT-3, if you are unless you're on GPT-4, but even GPT-3, they have some mix up when we use embedding. So the OpenAI embedding from the ChatGPT 3.5 is still not very accurate. So let's try to run it until we get, okay, let's now example. Okay, what is his job again? Oh, he's the boss. Okay, sorry. I forgot his status, so I should ask him something about his status because like most of the question will be involved in terms of status. So now I will ask him like, what is the next campaign strategies? Let's try it. Oh, okay. So he is able to answer it, right? Like the answer seems to be matched with my questions, but he seems to be very cranky right now. That's what I can see. Therefore, he is not giving me any answer. So what you can see is like they do have personalities, right? It's not like you asking ChatGPT because like whatever you ask ChatGPT, it might give you answer. But here you are building characters, you are building personalities. Therefore, the result, the response might be very different from what you expected, right? So you can play around with it and you can ask like run conversations, for example, run conversations. Here, run conversations. And you put in the list of Tommy and Alex. And what is the next campaign strategy? Maybe Tom. What the name? What his name? Tommy. I forgot his name. Tommy without the S. Sorry. Right. So now, like, I'm trying to let's see if Tommy and Alex, what do they talk, right? So here, Tommy said something about recommendations movie, and Alex recommend him to watch a movie named Hangover. So they are having conversations, right? They are having conversations, and Alex seems to be nicer. Okay, and you would see like some repeated sentence like this. It's very understandable. Because like we set out the tokens length, the minimum tokens, so they have to run all of those tokens before it ended. So there will be like some repeated text here. It might not be perfect, so there's still some post-processing coming out from the user to actually achieve the optimal results coming out from this. All right, so that's the idea of it. Right. So in the meantime, you are allowed to explore more from this, which means like you don't just have Bob, Tommy, and Alex. You can create your own in here with your personality and your daily goal. So your goal should be fed into the status. And yes, that would be your own work right now. Sunita, do you still have problem with your API? Oh, really? Okay. Yes, I might be able to assist you after this one. like what the errors say. Can you like copy and paste the errors here for me so I can see it? You can ask anyone to have conversation with, right? If you want Bob, you can just Bob here. Yeah, if you just rename it to Bob here. Perfect, easy, right? All right. I think like you are still using your API. That's why it gives that errors. Because I think like every other student still be able to run it. So are you sure like you get the new latest version of my notebook on my website? Right, make sure like if you click on the notebook, I think you can run it from start to end easily. There would not be any errors, right? So I think like you are still using your API. Uh, all right, so that should be it for today. And as I mentioned, today we are learning about how to use large language models for evaluations. And what we have done so far is to learn how to use user profiling. And user profiling has come into two parts: user profiling and user modeling. It has 5 steps from unstructured data to structured data, and then we can convert in an embedding. From that embedding, you can apply any supervised learning model like classification or regressions models. And finally, you have to optimize and evaluate them using RMSE or accuracy metrics. Then, however, like it takes a lot of complexity and times to run it. Therefore, we will try to improve it using agent LLMs. So again, agent LLMs is a specialized large language models going to do one specific task, right? If you are having like LLM for coding, there's only working on coding. It would not be performed on any other task. And you can also perform it for evaluations. But the problem when you're using agent AI for evaluation is that like it only have one personality. So like it don't give you multiple opinions, and that is something you might look for when it comes to the real evaluations for the content of or a story. So the final one we have is generative agents or generative LLMs. What it does here is like it create different personalities that you can set up with, like from the personality trait, jobs, age, all those things together combined, fit them into the GPT model, and it will act as different people that has been simulated from the real world. The good thing about this is like it can do a lot of opinion giving, which means like all of the prompts you are going to give them will get different results. And it is good because like you might need to collect different responses from people. So generative agent is very useful for people who want to do surveys or who want to do like opinion collections because it saves time and saves money. However, it cannot do specific tasks at a high professional level like agent AI. So be aware of what you need to do for when you choose the model to be applied on. If you want to do a very complicated task that requires like power NLP knowledge, then we are going to do agent AI. It's very specialized, it's very efficient, right? But if you want to do something that is require different personalities, different opinions, then we use generative agents. If you want to do something as a baseline model, very simple to run through and to get you like a very basic information of your data set, then we follow the traditional profiling fundamentals. Right, so I think I have gathered most of the thing, discuss some future research. Yes, so like for the research of this one, so because like I introduced like many concepts, so I can only focus on one. The only features that we are looking for is the generative agents. Like from my research direction is to use generative agents. So the problem with generative agents right now is like it cannot be done with multiple models, multiple modalities, which mean like it can only deal with text data. but it cannot be deal with sound data or voice data or signal data or images data. So that is the problem right now for generative agents, because when you experience it from the Python notebook, you would find that like it's very hard for you to inject the informations to different agents, right? Like you can only prompt and type in for Tommy to understand what you are trying to build for him. But if you ask him to look into a pictures, for example, it's very hard. If you see the code there, it's very hard to ask him to evaluate a picture. So at the moment right now, generative agents can only be done with text, and in the future we would like to extend them in different modalities. And furthermore, is like even though generative agent is powerful, but their application and adoptions in multiple fields is quite limited. So, for example, we also want to see in the field of medical, if a person got COVID, how he's going to move around, how he going to impact on other people, something like that. And we have that before, like agent modeling. But in this one, the generative agents, it will give them the freedom of choice, which means like they can walk everywhere they want, they can interact with any people they can. And we try to create a free world in the virtual world to see like how the simulated world going to end up with the COVID. So that is like the real simulations for the medical field has not been discussed clearly in generative agents. Yes, any other questions? I'll just open it now. Decide optimal of number of agents in that there's no optimal, right? Like for example, like how many people you want to have opinions on something, that depends on you. 10, 20 doesn't matter, right? The more the merrier. So that would be very good questions, right? Because like we cannot just keep making avatars, but we need to think about like the real life context, like how many people do I need to check if this book is good or bad, right? So it should reflect the real life situations. Yes. Okay, so that should be it for me today. And I will stop sharing my screen. I will stay a while for a bit in case like there's any questions. Right, the website of my notebook is still available online for you to come in and try to work on and do practice if you need it. Okay, otherwise, I'll just stop sharing my screen now. How do we prioritize against the different agents? Like you mean like how do we define the traits of them? How do we prioritize which agents from the others? I did not understand the questions. What do you mean like priorities the agents?
I think the question is about like ranking. When you have multiple agents, how do you decide which one is good or bad?
Like there's no decisions. Like for example, you are creating a person who good at math and person who bad at math, and you are asking a math problem, then obviously you will rank the person who know math, right? Just like human, just like a real life scenario, right? So it depends on the expertise of the person you created. There's no ranking there. Yes.
So this is all about reflecting the real life human
Yes.
behavior.
We
So
are
like,
trying to project.
yeah. So essentially, we are trying to make the agents that can simulate our behavior and act as similar as us. So as Stephen was saying that if we want to review a book, and if it is, let's say, in data mining category or machine learning category, you would like to have some who has expertise on the topic, some have immediate like intermediate expertise, and some may be from the computer science field but may not know machine learning. But you may not like it to go to completely strangers, because they would not have any technical experience. So you need to kind of be careful when you create these agents, and that what traits you want to reflect onto. Yep,
Thank you.
that is so important, continual learning. And that's why continual learning is really an emerging area in machine learning, because we do have this catastrophic forgetting problem in deep learning algorithms. So we want to have this continual learning to overcome this catastrophic forgetting problem. Like it's a typical of human behavior. We do the lifelong learning. So these techniques become very important in the deep learning scenario as well, and then the agents. But again, like as Stephen was saying, in terms of the limitations, we do have so many limitations of LLMs right now. Like we all know GPT-4 is coming soon, and that might change the field. Like I was reading something, and they are claiming that with GPT-4 you can make the whole movie of 3 hours. So I guess that would have a lot of like how we look at some long chain prompting. So this research is really very evolving, and so many new areas are emerging. So it's a very interesting and exciting field of research.
Yep. Thank you.
So, yeah, if you have got any burning questions, please ask through the chat. Otherwise, Stephen has presented an excellent session today. Very much what is on top of everything, and he got exposed to really a very high tech companies where he worked on Gen I and
Yes.
implemented those things.
Yes. So if you have any questions about your implementation, my emails and phone number is on the website, so you can contact me if you need it. Yes. I,
So, is there something that Namita's team you would like to add here? I don't see Namita here. It's a Sunday, so she may not be around right now. Uh,
Thank you.
Thank you very much for appreciating the session. And so next week now we would have the last technical session, and that is also very important. Safety, and we use LLMs, but we need to use it with the guardrails and the precautions. So we are going to look at the very important topic of safety and lifeguards. So Joy Wong, she is going to present the next module. And then the Sunday would be the last module where I will encourage you to come up with some of your questions, some ideas that you want to further take into the research, and talk about its validity. And we would be happy to collaborate with you. We got so many members in my team presenting different kind of problems. So see which problem you want to take as part of your research or teaching or in your industry, and how do we go along with. Yeah. So if there are no particular question, we can wrap up this session now. And if MNIT Jaipur team has to add something, they can add. Otherwise, enjoy the rest of Sunday. Um,
Okay. Thank you guys coming. Thank you, Professor. Yes.
Thank you, Stephen. Thanks so much.
Yes. Thank you.
Okay, so I think me and Stephen would leave. So have a good night. Bye bye. See you next week.